Hello and welcome to Algebra 2, Chapter 2.3, and today we're going to discuss quick graphs of linear equations. A few definitions to start out with. Remember, the x-intercept is the point where the graph crosses the x-axis. So if I was to graph a line, there is the x-intercept. Okay, it is a point, so it has an ordered pair. And it's probably good to note that its ordered pair is always x0 because it hasn't gone up or down at all. The y-intercept is the point where the line crosses the y-axis. So, there we go, y-intercept. And its ordered pair is always 0y, right, because it hasn't gone left or right at all. And hopefully you remember slope-intercept form, y equals mx plus b, where m is the slope, so your rise over run, b is your y-intercept. And to graph from slope-intercept form, we're going to plot the y-intercept first, because that would be our starting point. And then we're going to count the slope to find 2 additional points. I do like you to graph 3 points if you're using slope-intercept form, just because you can draw a straight line between any 2 points, but it's any 3 points that if you get a straight line, hopefully you've done it correctly. So we're going to graph y equals 1/2 x plus 1. Notice this is in slope-intercept form. We have y equals mx plus b. And so it might be good to note that your m is 1/2. And remember, you want your slope to be rise over run. So if your slope is a whole number, you're going to put it over 1. And b is 1. And so you just wrote down to graph from slope-intercept form. We're going to start by plotting the b. So put a point at 1. And my slope is go up 1 over 2. Try not to go up 1/2 over 1. Just go up 1 over 2. It's hard for me to hit these. Let's try something like that. Alright, do it again. Up 1 over 2. And in fact, if you want to do it more than twice, you can. Keep in mind that you can also go down 1, back 2, down 1, back 2, and it keeps that same slope. So if you're putting a negative with both of them, that's essentially a positive, so that would keep your slope. Alright, when you draw lines, I do want you to draw it through the graph. Don't just draw a little bitty line that connects your points. Draw your line through the entire coordinate plane, and there we go. So slope-intercept form is one form you can have a line in. Standard form is another form, and it's ax plus by equals c, where a and b can't both be 0, because if they were both 0, you wouldn't have any variables. And in a true standard form, a, b, and c are integers where a is positive. Now you can have a variation of a standard form, but in a true standard form, that's what you get. And so to graph from standard form, you could do it 2 ways. You could change it into slope-intercept form, which you shouldn't have any problem doing that, or you can graph it using your intercepts. And it turns out that graphing using your intercepts is a quicker method of graphing from standard form. So keeping in mind that at your x-intercept, y is 0, okay, and at your y-intercept, x is 0. And if you know that information, then you can graph your intercepts. So we're going to graph this using standard form, which means from our intercepts. So I always do a little list. So I'm going to find my x-intercept first, and I just wrote down my x-intercept, y is 0, right? Because on the x-axis, you haven't gone up or down at all, so y is still 0. So you're going to make y be 0, and you're going to solve this for x. So I get x equals 2. So there's my x-intercept. And then my y-intercept, x is 0, because on the y-axis I have not gone left or right at all, so x is 0. So if I make x be 0, and I solve this for y equals -3. Alright, so there are my 2 intercepts. So intercept form is the only form that I'm okay with you just graphing 2 points. You should probably just find a third point, but I'm okay with 2. So there's my 2 intercepts. And we're going to draw our line. We're going to draw our line through it. There we go. Okay. And to finish the problem, it does say rewrite the equation in slope-intercept form. So I'm going to do up here y equals. So once I have it graphed, you can count your slope. My slope looks to be up 3 over 2. So 3 halves x, and then my y-intercept, which I found, minus 3. Do not put plus a negative 3, please, just do minus 3. So from my graph then, I've written it in slope-intercept form. The last thing we're going to talk about is horizontal and vertical lines. So horizontal line has the general form y equals b. Okay, and if we remember just from a minute ago what b stands for, right? B stands for your y-intercept, because if you draw a horizontal line, it has a y-intercept. Okay, it is the line where all the y's are the same. So let's say they're 3's. That would be the line y equals 3, because all of those y's, every single y on that whole entire line is 3. Keep in mind also that the slope for that line is 0 since it's horizontal. And for vertical lines, there we go, we use A just because B stands for something in particular. So that is the line x equals A, which is all the x's are the same. In this case, it'd be x equals negative 2. And keep in mind that the slope of that line is undefined. Alright, so to graph horizontal and vertical lines, you really don't need to plot any points. If you realize the graph y equals negative 2, every y is negative 2. So where do I find all the y's negative 2? Right there, every single y is negative 2. So that is my line. And x equals 3, where the x is all 3. Right there, every single x is 3. There we go. Let me know if you have any questions, and have a great day.